All right, welcome to the August 23rd Gamma meeting. This meeting is governed by the CNC, the Kubernetes Code of Conduct. Can't remember if I'm in. About the Kubernetes Code of Conduct, which boils down to be kind to one another. So keep that in mind as you're being a part of this meeting. I'm going to go ahead and start sharing my screen and take a look at our agenda for today. And we've got a couple of agenda items on the meeting notes. Like I said, if you've got something you'd like to talk about, please go ahead and add it to the agenda here. I wanted to kick things off by talking about the DNS-sized elephant in the room. I brought this up in the Gateway API meeting yesterday during kind of a status update. And DNS has really popped up a lot because it's a very important piece of typical mesh design operations. Kind of lean on DNS to a certain extent. The greater Gateway API, like the ingress use case for Gateway API, seems to kind of sidestep that concern because of the binding to specific resources, so service or probably something like service import from a cluster or what have you. I don't know that we're going to be able to get away with that forever when it comes to the mesh use case, because in a lot of cases you're intercepting traffic and forwarding it based on a host name or a host name is the typical use case. So wanted to get some folks' thoughts on DNS and whether they think we need to have a GEP for that. That's been tossed out, or just some other clarification about around the assumptions you want to make around DNS. So I'll leave the floor open.
To clarify, I don't think at least Istio is not intercepting based on host name. Everyone is as far as I know, intercepted based on the VIP, on the IP address, because the application is making a DNS request by itself, and then it resolves to an IP, and that's what we intercept. I don't know if other vendors have a different solution, but I'll be curious to know. So it's implicit that everything that the user is doing, every request that any call, is going to be resolved by a DNS server to an IP address. That's I think it's implicit, and normally it's a kube DNS or whatever the cluster is providing, and is managed by the service entries.
I apologize. I was having a little bit of audio issues on my end, but I think the big takeaway between what I heard and what you said in the chat is that DNS is typically implicit and translating that host name to IP address, and that people aren't typically intercepting on host name, which I misstated. I don't think people are intercepting based on host name, but host name is used to like match traffic as far as client server, things like that. So yeah, sounds like we're good to keep that implicit. Is that what I'm understanding from you, Costin? Okay. Anybody else?
So it sounds to me like, the way I've been thinking about it is that one of the biggest things that you want out of a service mesh is the ability to define relationships between services or routing between services in terms of the services identity. Like, I'm using the word identity in a slightly fuzzy way, but like in terms of like what you call the service, you want to be able to use some name for the service and say, allow traffic from service A to service B. And you don't want to have to say service A always has this IP address or service B always has this IP address or something like that. I appreciate that there are other things where you've got to say, allow this, allow like a CIDR or something like that. But like in general, I think one of the biggest things you want is to be able to not have to worry about the IP address details and be able to let the infrastructure sort that out. Right? Like that's one of the biggest reasons you want to have a service mesh, right? So I think that's that in my mind, that seems like the biggest thing that we want to make sure we're doing is that we need to ensure that there's some idea of a service identity, right? Like there's the reason I like using that term is that it feels like that handles that front end use case that you documented so well in in the initial thing. But it also sort of implies that if you are doing some sort of MTLS auth, then the identity is kind of bound up in that, right? Like, and so that the identity also, I mean, like the workload identity and the service identity are probably going to be related. They don't have to be, but if you are doing it, they're going to be closely related, right? Like, because you don't have to do workload identity, we can't say it must be that way, but it's possible that they could be. Austin, you unmuted. Do you have something?
Yeah, I mean, you are getting close to the referred interoperability, and I would love to have an agreement about what is identity of a service if you use MTLS.
Yeah, I think. Yeah, like I said, I guess what I'm trying to say here is I feel like talking about it as a service identity just means that we have space later to talk about that. I don't think we need to solve it right now, but I think we just need to make sure one of the things I've learned from doing the main API is it's good to make sure that you leave space for problems you will have later. And so this is a problem that we know we will have later, and using the word identity sort of then lets us bundle up that problem, kick it down the road. That's what I'd like to do here is sort of say, hey, let's call this the services identity. That includes, certainly some sort of name for it, which will be a DNS name, and then it's up to the implementation what you do with the naming. I mean, for Cilium, right? Like Cilium has its own set of like pod ID, like UIDs for things. That your UIDs for pods. That's actually what Cilium uses internally because there's a lookup tables in eBPF and stuff like that. And so like, it works a little bit differently, but at the end of the day, you've still got an identity that you're associating with some stuff.
But one thing I want to make sure we're in agreement that is we are not reinventing DNS, IPAM, address allocations, or other things in most cases. I mean, we may double there if necessary for external or for some stuff, but we still rely on IPAM and kubedns effectively for Gamma. Okay, as long as you have agreement on this, I think it simplifies the problem a bit.
Yeah, I completely agree that we don't want to re-implement IPAM or DNS because there's some people way smarter than me who are doing that, and I want to leverage that layer of abstraction as much as possible and not get into those details because it can get hairy. So big plus one.
That has implications that we are still service centric. So the service object which allocates the IP and the VIP and the name are going to be kind of centric because that's the center of identity, really, what we're talking about. That Nick was saying.
Yeah, I think that we are certainly going to be service based. I think, yeah, like I said, like I've said before, I think that there's the split between the front end and the back, like the conflating of the front end and back end concerns in the current service object means that we might have to do something clever there. But like, are we going to end up basing it around that service object? Absolutely. I mean, it's the object, right? Like it's the thing called service, right? But I think that we need to be really clear that it may be that we have to bind things to some intermediate thing or something like that to make that split clear. Because I think that split between front end and back end is most likely to be the thing that burns us, in my mind.
Or we push the back end out, or we kind of decouple the back end in a different way.
Or something, yeah. I mean, I think decoupling the back end will be very difficult because the rest of the gateway API already expects the service resource to be a back end.
Oh, you mean as a name, but I was talking about, like endpoint slices. I mean, because it's already kind of decoupled. The backend is actually represented by endpoint slice and endpoints. So it's.
Yeah, true.
So what I'm hearing is, what I think I'm hearing and parsing from this conversation is, it doesn't sound like we need to create any gap yet, just making sure that we're careful about keeping DNS implicit, not reinventing DNS and IPAM, and keep everything service centric, even if we have logical or intermediate representations of that front end back end duality of the service.
I would write it down as keeping everything service lowercase s centric, not uppercase s. So it just to be clear that, like, I think that this is terminology that we need to be really careful about, because I think that the The uppercase service means the literal resource Kubernetes service. And if we use the lowercase service, then we're talking about the general concept of a service. And I think if we talk about the general concept of a service, then we have a bit more freedom to be flexible about exactly what resources we use to do that. Yeah, so I understand, Costin, that the uppercase service has that, but like the important part here is that there's some DNS or VIP binding somewhere, not that we use that specific instance of it, right? And so if we use the lowercase service, it just means that we can talk about this in a standard way without being stuck with it means that we can change our mind about exactly how we do it. We can flip backwards and forwards until we can't settle on a final solution. I just think it's really important to be clear about the terminology we're using. Can you hear me? Can you hear me at all?
I can
Keith?
hear you.
Yeah.
Oh, this is- yeah.
Cool. I'll just put some notes in there while Keith sorts his audio out.
Okay, I can hear everybody now.
Welcome
Apologies.
back.
My headset's been causing me grief for the past 2 weeks, and I'm about ready to chuck it into the ocean. So yeah, so I agree with what I heard from Nick as far as with lowercase service. I think I was trying to strike a balance between what Costin said, like we're not looking to recreate the service resource. We want to let Kubernetes handle the DNS, IPAM, allocation magic, but our design should split up the front and back end duality of service, or at least be aware of that split when designing. Okay. Okay, any other comments before we move on to the next topic? Okay, so next thing for us to talk about is the mesh representation gap. And I've gone through and added some more detail here. I already had it up. I copied over the approaches from the exploration doc because now that we've got, I forget the number, but the main kind of service mesh goals get merged, that gives us the what and the why. And I think we need to move full steam ahead into the how. So I'd like to spend, I'm conscious of other people who might have agenda items. So if you have another agenda item, please let me know. But I'd love to spend some time synchronously talking through some of these approaches and try to get some clarification on where this gap needs to go. What are our winners as far as, or what are the front runners as far as approaches here? And do we have any approaches that are just kind of non-starter for anybody's implementation? I'm not making any final decisions here, but just trying to get a signal from the community of what makes sense. Does that sound good, everybody? Solid. So I won't read this entire thing, but basically, I always struggle to write some of these TLDRs because they kind of seem obvious. But like, if we're going to do mesh with Gateway API, we need a way to represent mesh in Gateway API. So goals here, I want to provide a consistent way to represent a mesh Gateway API. And there's a comment, a good comment, asking about the scoping of this to one mesh. I think scoping this to a single mesh makes sense at this juncture because the multi-mesh use case would be a natural extension of a single mesh use case. Representation should allow implementations to refer to ingress gateways, for example, Contour or Istio ingress gateway, as mesh resources for the purposes of MTLS or route generation. There's a lot of confusion about this. It's gone through a couple iterations. It wasn't very clear. So it might not be clear. So let's talk about it. Basically, what I meant for this goal is that, a lot of meshes, take Istio for example, have a kind of bundled ingress gateway. That's maybe a wrapper around Envoy or around the proxy or what have you. And those are kind of like first-class mesh resources. They're programmed by the control plane and things of that nature. We need to keep that in mind and not assume that the I guess lowercase gateway, the ingress gateway data plane, you should not assume that that's going to be a separate instance from the mesh. The mesh should be able to refer to and understand the ingress gateway. And that's kind of what I put here. Mini mesh implementations integrate with various kinds of gateways. Whatever scheme we use for mesh representation should not prevent meshes from continuing to operate in this way. So like I mentioned earlier, this has had some questions and needs some clarifications. I'm happy to try to talk through this synchronously now. Costin, you got your hand raised?
Yeah, so it's a bit broader problem. It's not only that Istio has both a gateway and a mesh implementation, and we want the UX to be, good for people who use both. But it also raises an interop, which is, keep discussing, and is not in scope for the first phase, but eventually will have to happen. Is that if you have a gateway and the mesh, the gateway should be able to communicate with the mesh. So if you have one implementation of gateway and another implementation of the mesh, it should be some way for the user to know that if the gateway is referring to a service that is in the mesh, it will not get forward some errors. I think that's a requirement to show.
Yeah,
Yeah.
definitely.
So,
but I think
do you feel that's represented in the current state of this, or am I misunderstanding what you're saying?
I don't know if it's, well, depending how you parse it, maybe it's implicit, maybe not, but it will be good to be explicit that the gateway implementation and mesh implementation need some form of not breaking each other.
Yeah, that sounds reasonable to me to be explicit about that as a goal.
So I think there's two things. Firstly, that they need to not break each other like on the implementation level, but also they need to be consistent on the API level, right? Like the gateway API, like the gateway API as used for ingress needs to like not be fundamentally contradictory with the gateway API as used for mesh, right? Like, I mean, I feel like that should go without saying, but one of the things I have learned from writing a spec for like 3 years is that all the stuff that you feel should go without saying, you need to actually say, because otherwise someone will not assume that you said that. So yeah, it's better to just be extremely explicit here and say like, yeah, like that. Yeah, I think that's what you have there is really reads really clearly to me, Keith.
Solid. I really think that gets at the heart of what I was trying to represent here, but I went through a very convoluted way of trying to say it. So I might just delete this since it seems to create more questions than answers. And it'll be in history if we ever need to go back and get it. Any other comments on that particular goal? All right, moving on through. I said the last goal is, however, the representation must make no assumptions about the existence or inclusion of any gateway within a mesh, including sidecar proxies. So again, the idea here is that even though the implementation of mesh representation should allow for gateways and meshes to coexist and not break at the implementation and API levels, we also shouldn't assume in the spec or implementation that, well, we shouldn't assume in the spec that a gateway exists or is included within any kind of mesh. And that includes sidecars. We also shouldn't assume that sidecar is the topology that the proxies are going to be delivered through.
Speaking as someone who's responsible for a sidecarless mesh, then yeah, I really appreciate that.
Awesome. Those are the goals. Way back when I started this, we didn't have the why, so I was striking out a bit on the non-goals. Anybody have any obvious non-goals for mesh representation? I think multi-mesh, that sounds more like a deferred goal rather than a non-goal.
Yeah, I think I actually saw another one. It's not in the standard KEP one, but another thing that yeah, just marked it down. Like, let's just mark them down as deferred goals and say, we will consider this, but just not now.
Solid.
Yeah, multi-cluster and what we do about multi-meshes in one cluster are a problem for later. Like I agree. I agree. Costin, you've raised this a couple of times, and I 100% agree that it is a problem. We need to ensure that we don't stop happening or we deal with at some point. But I feel like we should deal with the easy case first, which is there's only one implementation installed in the cluster, and then we deal with the hard case later. What happens if you try and install, but try and install two? Some of that may fall out from designing the like status flows and stuff like that for whatever resources we end up building.
That's kind of what my hope is, that we just intentionally make it so that we're not having like, oh, this is globally configured or something like that. So the same way that Gateway API references controller name for things, like I think we could follow similar patterns so that we leave design space for the future there.
Yeah, I think the controller name pattern for status is the way to go. For sure. I feel like that one we got right.
Yep, agreed. +1 there. Any other deferred goals or non-goals?
Multi-tenant.
Yeah, multi-tenant I think makes
Can you
sense.
explain a little bit more what you mean by multi-tenant?
You have completely different. I mean, it's somehow common to have a cluster and run workloads from completely different organizations, customers, whatever. And each of them is completely separated, different root of trust. They cannot talk with each other. They are, have tight control, like the namespace hierarchy in Kubernetes in some way. It keeps getting. Yeah.
No, I'm curious because I know that we have that use case on console, but like that's beyond the cluster. I'm kind of curious though, like within Kube, like how or if that is modeled.
Namespace per tenant usually, and then different root of trust and other stuff.
Okay.
Curiously, I'm just thinking about this now. But multi-tenant kind of fall within the scope of deployment model and the kind of the upstream deferred goal, and the upstream get. I say upstream. I'm overloading upstream, but in the previous step that we just merged in, it sounds like multi-tenant falls more in that deployment model story and kind of inherent. It's implicitly a deferred goal, so it might not. I mean, I guess maybe we can include it because we include multi-cluster and multi-mesh, so may as well include multi-tenant here. Okay. So
I think the important part we're getting out of that deferred goals section is if you are wanting to ask about multi-tenant, that's fine, but come back later. Like that's the, all three of those words are basically, sure, we're going to talk about that, but come back later, please. Like, don't hassle us with that now. We've got to deal with one mesh first.
Yeah, that's a good call. Okay, so moving on, we've got a couple of basic scenarios and use cases, and I think it was Mike who pointed out, but these are really cluster administrator kinds of use cases that as a cluster administrator, I can represent the existence of a mesh within my cluster. And that as a cluster administrator, I can opt a specific namespace into the mesh. Put those as use cases, but maybe this piece specifically should be, oh no, we decide, I'll go back and forth. We had a conversation about namespace enrollment being a goal or non-goal, and I think it was actually a non-goal on the GEP that we submitted earlier. I might be wrong, but I'm pretty sure it was a non-goal. But I do think that use case is significant enough to put it here as a use case, to realize that whatever representation scheme we come up with, folks are going to want to, do namespace addition, this granular addition of things. We need to try to think about that.
Maybe a more general way of saying the same thing would be better. Maybe it's like, instead of saying opt a specific namespace into the mesh, say something like, as a cluster administrator, I can control what namespaces have the mesh enabled. Like that's a more general way of saying the same thing, right? Like, because maybe like it sounds to me like you might want to have it be like that the cluster administrator can say every namespace gets it and you can't turn it off, right?
Yep.
Or you may want to be able to say only certain namespaces opt in, or you may want to do, everybody gets it and you can opt out, something like that, right? And that covers all three of those options.
Yeah,
But I would say workload, not namespace, because you may want to select which workload. In a namespace, you may have workload that can use the mesh and other one that doesn't. So, as is typical, I mean.
that's a good point, because even within a namespace, you might want to exempt certain workloads from the mesh. So that's a really good call out there. Yeah,
I think
really
that
appreciate
I feel like it feels like a classic sort of phase 1, phase 2 design, though, that the workload is initially bucketed by namespace and you handle the more specific use case later. But I don't disagree that this terminology is correct.
It's very common. It's common enough that I think we cannot defer to workload too much, because it's.
I doubt your superior experience in this case.
Okay, if there are no other comments on that, I'd really like to start talking about the approaches section. This is kind of where the Gamma, initiative started. With a bunch of folks on the mesh side wanted to say, how could this work? And this was, I think these 4 different approaches are kind of what as far as we got when it comes to brainstorming how this might be represented in Gateway API. The way they're organized is kind of based on the resources that they require. So the first approach would be to create a new standalone mesh class resource. And you can see an example here. We'd have a mesh class with a reference to the controller name. And it would mirror gateway class almost 1-to-1. And then mesh implementations would kind of register the mesh class, and the kind of, in this case, the routes would kind of bind to the mesh class. Another option is to just reuse gateway class, the same as the previous proposal, but we just kind of reuse the gateway class resource for the same purposes. Another approach would be to create a new mesh and a mesh class resource, where this would be kind of a one-to-one, a more accurate one-to-one representation of how gateway and gateway class are used, where mesh class represents a type of mesh. So maybe one mesh class would be Istio, another mesh class is OSM or Cilium, and then users would instantiate a mesh possibly within a namespace, possibly cluster one or whatever, and then things would bind to the mesh resource. And then another option similar, you do the same thing as this mesh class, but just reuse gateway. So there's more details here, and we can chat about those. But I wanted to, and Nick maybe about to say what I'm thinking here, but I want to get folks' opinions on the high level direction to go through with these approaches, or clarify any questions that folks might have. Go ahead, Nick. Then Mike.
I guess I just wanted to say my experience with the Gateway API, the thing that is kind of a general thing. The thing that my experience with the Gateway API has taught me is that Kubernetes resources that have too many behaviors or don't have extremely distinct uses, like, cause problems. Like if you think about service, the resource, it does a lot of stuff, and the more stuff that it does that are not entirely distinct or that overlap, the harder it is to design a spec around it. And so so I think that that's sort of a long and superior level for me to say I'm -1 to anything that involves reusing existing resources. I think the use case of the mesh is close enough to the case that to the gateway case, like the concepts are similar and close enough, but at the same time different enough that if we don't use different things, it's going to be very confusing and very hard to understand, and too magic is the sort of, and I guess that's if I were to sum what I've just set up in 2 words, I would say beware magic.
That sounds like my I used to be a Ruby dev, and I got that advice a lot. Mike, go ahead. Then we got Costin and Rob in the queue.
Sure. So, like, I think one of my initial questions is wondering like what the role of mesh class is. I think that like mesh as like a concrete implementation makes a lot of sense. And from like a gateway API, my understanding is that for some implementations, gateway class maps to like a physical load balancer or different types of load balancer or something like that. For software defined implementations of the gateway API, it's not a particularly meaningful abstraction, at least for us, it feel like it hasn't been. So yeah, that's kind of my question is like for the mesh case, what is that distinction, or is it more useful for some implementations? Like I think Kuma comes to mind, where they have like a partitioned mesh of some sorts.
Completely agree with the mesh class, but we agree to defer the multiple meshes, so that's where probably it will come in. I completely agree that it's useful to be very explicit and to have kind of explicit CRDs for things that are different. So mesh class mesh, for example, if we use mesh to select the namespaces workload, that's a very reasonable thing. But I just want to make sure we don't create too many resources and too much user overhead. So if something, some routing or some policy attaches to a service, it's a policy attachment to a service, that's reasonable to say, hey, I'm attaching to the service and not create another mesh. So not one mesh per service and then attach to the mesh just because. That's my, okay.
I raised my hand and then everyone, I think I just am going to repeat what everyone else said. But for the record, I will say the same thing. That is, I echo what Nick said. We want to avoid reusing resources where we don't need to. I think that the idea of a gateway is, to me, different, and especially a gateway class is different than what we're trying to do with mesh. I would rather keep those different. I absolutely am completely in favor of reusing mesh policy, reusing routing policy, etc. I think that's the whole point here. And then I would echo the question of what actually goes into this resource or resources. Like the mesh class, if that's really all that we need in a mesh specific resource, then it seems like we only need one resource. But there was another proposal a bit further down for mesh class and mesh resources, and it wasn't clear to me like what would go in if you have two resources. What does that really mean?
To mesh implementation, it was for the multiple mesh implementations like in gateway, but we agreed to put it in the default list anyway. So
yeah, so there are, I forgot to add this, but in the original document, there are a lot of good examples on what this would look like. So, mesh class struct attachment, and these are kind of like walking through the flow of what it looks like. So you do a Helm install cool mesh, which would be a specific mesh implementation. That would install a mesh class resource describing the mesh automatically within the Helm chart. And then you create a mesh resource to enable the mesh in the namespace. And then at that point, the HTTP bit namespace has the service enabled. And some, this might enable some implementation specific behavior like encryption or telemetry or whatever. There's no like gateway API driven behavior here. Then we deploy the service, and this gets into like service attachment. So this is kind of a walkthrough of how this might work. And I'm personally, I kind of like this story. I think the concepts map nicely. One question that I have as far as mesh class that my gut is telling me to punt on is perhaps mesh class represents different versions of different implementations. And when you go from version A to B, you create a new mesh class. I'm even just saying that, I'm like, that's a lot of stuff to try to figure out for this initial sprint. But having that piece there, even if it originally doesn't do much, I think is something worth thinking about. Go ahead, Nick.
So I think the key thing is to me that I think in gateway class and gateway, the relationship is clearer, and it's more. I feel like it's less common that you have like gateway. Like I think the gateway is easier to understand why it would be namespaced. In my mind, the mesh resource that you've got there, it's hard to understand in my mind why it would be namespaced. But like it feels like what you're using the mesh resource there for is really like enable this namespace for the mesh, and the mesh is actually being described by the mesh class in the example that you've got there. So the question I would ask is, why not then, just make the mesh cluster scoped? That lets you sort of have some rules around like what you having multiple meshes and stuff like that have to be distinct, and they need different config of a few things. And if you want to upgrade to a new version, maybe you handle it with a separate cluster scope mesh resource. And then you have some other resource that handles a selector or some other way that you then enable the mesh on a per workload basis, or enable it on all of them. The good part then is you put that into the mesh, and then that describes those things in a general way. Right? Like I know from my experiences using Istio a long time ago, you've always been able to label namespaces and have them be like, this namespace gets the sidecar proxies injected, right? Like, and so that sort of enrollment thing where you put a selector in the mesh that says namespaces with this label get enrolled, or have their workloads enrolled, to use the terminology we agreed on before, like that then leaves that decision up to the cluster administrator, and there's a standard mechanism to describe it, right? Like, you're using a standard mechanism. And so I guess that's the question that I would ask is, like, I agree with Rob. Like, it seems like the mesh class is not serving the same purpose as it does with the gateway class. I put it in the chat. Sorry, Costin, I see you're on mute. I promise I'm going to hand over to you a sec. The way that I think of the gateway class is it's the sort of description of the implementation plus its config. So it can be useful for a single implement. Like, it's possible for a single implementation to handle multiple gateway classes if that controller can handle like generating data paths with different config. Whereas I think in the case of a mesh, it's kind of a higher level construct, right? Like the mesh is really, in my mind, more analogous to the gateway class than to the gateway. Okay, sorry, Costa.
Yeah, the reason I like the mesh as a per namespace resource is that, first of all, it's very analogous with gateway, meaning that it selects a number of workloads and gives some control to, you have RBAC as a cluster admin, you can set RBAC rules to prevent users to modify or to control who can create the mesh objects. But at the same time, you can give permission to some people, to some namespaces to, control which workloads are enrolled, which workloads are not, and to have some control over the behavior of that namespace. Labels in Istio, I think, were a mistake because it means that you need to give permissions on the namespace itself to edit, which has a lot of implications and dangers. And it's also not a right granularity because we also have to put labels on workloads, exclude, and all kind of other complicated stuff. And you have to annotate the pods. So having an explicit mesh that selects workloads by label, by whatever, that's an improvement versus what we have, I think, with Istio and not most other implementations. And the reason we put label is for injection, basically, to control the injection, but that we can do it through a controller.
I think you're right. Yeah. So maybe labels does have a lot of, especially namespace labels, have a very big security blast radius. Giving someone namespace label access effectively gives them cluster admin, because you can privilege escalate into cluster admin from namespace access.
But it's also the workload, because we need to opt out some workloads or to opt in some workloads. Again, you need to do it through labels, and then you need to give them permission, and it's very hard to control access to the labels.
Okay, so I would draw my thing about label-based labeling on namespaces, but I think the other question that I asked still stands. Like in my mind, like even if you have multiple meshes in a cluster, what you're talking about using like a namespace mesh resource is really enable the already existing mesh in this namespace.
Yeah.
So I think that we should call that something else. Like that the thing that lives at the cluster level is the mesh definition.
Mesh class.
And that then makes the mesh. So, but I think mesh class is actually a misnomer, right? Like you've really got a mesh, right? Like you've got a service mesh, right? Like you're not having multiple service meshes within the mesh class, which is what the name class implies, right? Like it's kind of like the reason we use gateway class is it's kind of usual and expected for you to have multiple gateways in a cluster that are namespaced that have different that are like different data paths.
And same is true for the mesh. I mean, you have even Istio may have different. I mean, you have Istio permissive, you have Istio strict mode, you have different version of Istio. So it's even if you have a single implementation, you may have variations that at global level have different settings, and you may want to control a namespace has this particular setting or this other one.
Yeah. So I guess what I'm saying is I feel like we need to be careful about using the suffix class, because the suffix class implies that it is a bucket for holding a more important resource that is another resource, right? Like, so if we're going to call it mesh class, like that implies that the important resource is actually the mesh. That's the pattern that is used elsewhere, is that storage class is a descriptor of like how you instantiate like storage units, right? And a gateway class is a descriptor of how you instantiate gateways, and an ingress class is a descriptor of how you instantiate ingresses. And so like what I'm trying to say is like the mesh is inherently like a multi-namespace, almost cluster level thing, right? Like because the whole point of it is to describe communication across like a large chunk of the cluster or the whole cluster, right? Like, if you're going to have, again, this does come into if you're going to have multiple meshes, but if you're going to have multiple meshes, the things that run the meshes have to have effectively close to cluster admin permissions, right? They have to have extremely wide ranging permissions, and like they need to be able to create lots of stuff, not just like a data path. I think that what I'm trying to say is, yeah, cool. Okay. So what I guess, yeah. So like, but I think what I'm trying to say is like, I feel like it'd be better to call the cluster level object mesh, and then have a mesh enrollment object that makes it very clear that that's what the thing is, right? Like this is an argument about semantics, I think, but like I think that in this case, the semantics, yeah, like are really important, because the class suffix has a very strong imputation that I don't think that what we're talking about kind of like follows. And that's what I'm trying to say. Like, we don't want to bring the way that people expect things to work into a thing where it doesn't work in exactly the way you expect. Again, magic.
I would agree with you with the conclusion, but not with the premise. I mean, in terms of behavior, I mean, in gateway class, and I don't know if the name is right or not for gateway class either, but in gateway class, a class represents, both an implementation and a particular set of behavior. You have internal, internet, egress class, or whatever classes you want to define. I mean, for JK, you have, again, global, and so forth. So it's how it's different from how gateway is used. I mean, have a mesh class which or storage class, whatever, which defines a particular storage, and then you instantiate it. That's what we are doing in a namespace for the workload. In that namespace, we instantiate, we provision whatever is necessary. Also to selection, because again, a mesh and the gateway, both of them select some workloads that will happen to have the properties of defined by the class. So it will be even more confusing if we define new names and different names from gateways, and if we repeat, and kind of keep it consistent, even for gateway is not particularly ideal to call it class and other stuff.
I guess what I'm trying to say is I actually think they should be different, because I think that keeping them too similar is that we run the risk that they're similar enough to be easily confused, and that people may bring imputations about the way things work that don't apply. And so, like, in my mind, like, having things be different sort of says this API behaves in a slightly different way, because I think like it seems clear, like, I guess it seems like the problem here is just about what constitutes a mesh, right? Like, and for you, the mesh is the mesh enrollment, right? Whereas for me, the mesh is the underlying infrastructure that you can enroll into. And so, like, that's the key distinction that we're talking about here, right? Like for me, the mesh described the idea of the word mesh describes the thing, the infrastructure and the controllers and stuff that describe that sort of the underlying capability and then you enroll into that mesh in some method. And so having like the mesh be a cluster level thing, because that's the capability exists at the cluster level, and then you enroll into that capability, right? Like in the case of gateway class, like we kept the gateway, we used the gateway class name because I think you're probably right. You sort of said like, hey, the gateway class name is kind of not, I think we kept that for the correspondence with ingress, because ingress class, gateway class, like that was easy for people to understand. But I think here, again, the mesh use case feels different enough to me that it's really important that we give people, like, we make a hard break and be like, no, that's not how it works here. Sorry, Keith, I talked a lot over you.
Just a quick answer. I mean, I don't particularly care about how the mesh class is called. I think bike shading names is probably, because a lot of people will not interact with it too much. Probably it would be good to have a list of proposed names, and then people vote on names and sort them order, or whatever is typically done to resolve bike shading, because again, you will never find consensus on how to name things or what colors to use and other stuff like that. But important is to agree that we have, something that is cluster level that defines the implementation, and variant of the implementation, something that defines the enrollment. And if we have an agreement on that, then it's just a matter of picking random names and try roll a dice or selecting by vote or whatever other criteria.
Like I always say, there's two hard problems in computer science: cache validation, naming things, and off-by-one errors.
Just about to make that joke. So I think that more so than, to Costin's point, more so than naming, I think the important thing here is to make sure that we represent what we want to represent in the cluster, that the concepts behind this are solid. Naming can come later, but I think we need to come to consensus around what do we need to represent as far as resources in the spec. When it comes to different mesh behaviors, like you mentioned, SEO strict mode and things like that. Honestly, to me, that feels more like a setting in an implementation, as opposed to something that rises to the level of the spec. I'm also kind of in the theme of Gateway API. I'm also leery, is that a word? I'm also wary, I'll use that word, of creating a resource that will just lead to a lot of annotation proliferation. And I feel like thinking about this more, I do feel like having a mesh, having two resources and having one that's supposed to be some sort of description of different behavior for a mesh starts tempting implementations to just start proliferating a bunch of names, a bunch of annotations to represent their settings, so that they can sunset their particular resource. Like for OSM, we've got a mesh config object that you can set like your I'm blanking right now, but like the mode, like permissive mode, or different certificate providers or what have you. Like mesh class, that doesn't belong in a mesh class. That belongs in your implementation. And so the more I'm hearing from the conversation that just happened, I think my preference is a single cluster scoped mesh resource, because I think that aligns more with how much I think about a mesh. When it comes to like software defined gateways, like those are, again, within a Kubernetes cluster, those typically services. And services are necessarily scoped to a namespace. And so having this gateway class gives you kind of another layer of which to describe common behavior. But with a mesh that's looking at the entire cluster, all the different namespaces, it feels like the extra step feels like it's going to be more tempting and distracting than useful, in my opinion. So I think my preference is probably a cluster scope mesh resource. And it sounds like, based on where the conversation didn't go, it sounds like most folks here, at least, are pretty good with are pretty agreed upon like not reusing gateway and gateway class. So those kind of options go out the window, and it sounds like we're starting to narrow on an option or two. And I'd like to kind of throw out the possibility of let's get those two options codified in a GEP. And this, make sure I have a bad habit of not sharing things completely. I'll open this up to everybody can edit, and let's start like working on this to get this GEP submitted, because from here, I think it's going to become having this mesh representation GEP finished is going to make the next conversation, arguably the harder conversation around binding, easier. And so the more time we give ourselves for the binding conversation, I think the better. Go ahead, Rob.
Yeah, I just wanted to suggest something. Like I know we spent a very long time in the early days of Gateway deciding what belonged in a route and what belonged in a gateway and what belonged in a gateway class. And the way I remember it is we eventually tried to list out, here are the capabilities we want to represent. And without naming the resources, we tried to like fit them into buckets of things that work together. And can you fit them all in one bucket? Can you fit them in two? Can you fit them in three? Whatever it is. That may be a useful exercise here. I know we can get really caught up in naming. And it seems like most of us don't care that much about the name, but just so much about the capabilities and where they live. Maybe that's, just to build on your suggestion there of having presenting multiple options. Maybe those options are presented without names, even just this is the 2-tier option and this is the single tier option. And yeah, I don't know.
Yeah, all those names have lowercase names that don't imply the name of Kubernetes reference. Like that lets you kick the naming thing until you've actually figured out what fits into each bucket.
Yeah.
I would also say the other thing to remember is there's personas in the API for a reason, in the Gateway API for a reason. Also, we should also consider bucketing the resources by which persona controls them.
But do we have rough consensus about having something like mesh class and something like mesh enrollment, or whatever you want to call it? I mean, one to select the workloads and one to select the implementation or represent the implementation, and then spend the time debating how do you attach a route to a name, basically.
Yeah, I do
want to call out that in the original GEP that we merged, or not original, but the first GEP that we merged already, namespace like workload enrollment was explicitly a non-goal or a deferred goal. So if we cannot solve that, I mean, the status quo already exists for mesh implementations. Like we're not going to lose functionality by not putting namespace enrollment or workload enrollment into this. So I did want to call that out. Sorry to cut you off. Go ahead, Costin.
Then we also don't need the mesh class, because that's also deferred to have multiple mesh implementation of different versions. And it's also kind of comfort, which is actually very good, because we can defer this, the naming for this, and just focus on the first phase, which is how do you attach a route to something.
I understand what you're saying, Keith, that we put that as a non-goal. I feel to me like in terms of understanding how the service binding works, you can't understand that without understanding like what buckets the service bindings fall into, which is like roughly a mesh config. I like the SMI sort of name there, and I'm talking lowercase resources here, not uppercase resource names. So it feels like we've got broad agreement that there's like a case for a cluster scoped like mesh config of some sort, like, and some sort of namespace scoped way to, like, you're going to need some sort of namespace scoped way to enroll or unenroll, right? Like later on. I agree we can defer the exact design of that, but we can say, hey, the way that you would describe how that thing worked, how that mechanism worked, would belong in the mesh config, at the mesh config level, right? Like that. Yeah, that's what Rob was talking about, is that you want to think about the capabilities, and whether or not you're building them right now, you want to think about what level they belong at, right? Like setting the mechanism by which people can enroll their workloads, that belongs to the cluster administrator in my book. And so that then belongs at the cluster level resource, the mesh config resource, right? Like, and so that then says, okay, those things bucket into that thing, right? Like, and we have a spot to put that later. Like, so it's not that we're going to build it now, it's that we're going to make sure that we have the spot at the right level to put that stuff later, right? Like, so we're not going to fully spec out exactly how we do that, but there will be a way to like enroll or unenroll your workload into a particular mesh. And that the way that you define that capability belongs to the cluster administrator. Maybe we leave that as unwritten for now and say, hey, you install a mesh config, and that means everything is enrolled. End of story, because this is the simple case, right? Like, you know, and then but the capability then belongs to the person who owns the mesh config. Yeah, and then arguably you want the application developer to then be the person who actually does the workload enrollment, right? Like, and that then suggests designs that involve not giving them RBAC to labeled namespaces and a bunch of other stuff like that. But the levels of the personas who the capabilities belong to then is the thing that really you know, like that's the important part. And if you end up with only 2 levels, then that's good, right? Like rather than 3. Gateway has 3 because that's what we settled on as like the way that because it matched well to the personas.
Yeah, I see your point. I mean, if you want to represent a group of workloads that have a set of policies attached, then it may be a good use of the mesh or mesh. I mean, it's not going to be used for enablement. It will actually be used as a way to group workloads and to attach policy to that group of workloads for the purpose of policy overrides. You know, where do you attach the RBAC and so forth. So I see your point. I agree with that. If that was your point, if I don't understand.
I think like I wasn't exactly trying to say that, but I see where you're going. Like the point that I was trying to make was like, in order, I think that Rob's point about like how you design the system of this is you write down as many capabilities as you think of as you want the overall API to be able to handle, right? Like, you know, that user stories thing that you have in the sort of mesh definitions gap is a really good example here, right? Like, you know, like you want those are the sorts of things, and then you sort of take those and you bucket them into the personas and say, okay, this one belongs to the cluster administrator. You know, this one belongs to the application developer. This one belongs to the, so, I mean, technically we have 3 roles, right? The infrastructure administrator, the cluster administrator, and the application developer. I feel like most of the mesh stuff actually belongs to the cluster administrator, not to the infrastructure administrator. The infrastructure administrator is the person who like provisions the cluster itself and any infrastructure area outside the cluster. Service mesh in general doesn't expand past the scope of the cluster itself, right? Unlike gateways, which often involve provisioning stuff outside the cluster. And so that's another reason why we had the 3-layer structure there where we don't have it here. But like, because the 2 personas you're talking about are really, you know, the cluster administrator and the application developer, not the infrastructure administrator, the person who provisions the cluster and any shit outside it. Sorry, I keep.
Yeah, Shane pointed out in the chat that we are over time. So I want to thank everybody for showing up. Great discussion. I'm going to kind of create a message in Slack to kind of catapult the work on the gap in this Google Doc to eventually get something submitted in the PR. But love the thoughts. If you've got thoughts that are just overflowing, you want to put them somewhere, please go to Slack. That'll help us keep the conversation going. All right. Thanks, everybody. Have a good rest of your day.